For this one, we are going to be shading, and it's going to be some sort of inequalities, mostly linear inequalities. And after you graph them, you're going to shade where they're all true. And the region that's shaded is called the feasible region. So that's the possible answers, or all the shaded parts. And then, of course, the corner parts are the vertices. And the actual lines are called the constraints. So when we get to a story problem, the constraints will be, you can only mow so many lawns, or you can only use so many hours to produce something. And you'll have to come up with some sort of equation and graph it, and then you're going to shade it based on what it's talking about. So if it's bounded like this first one, where it's just some sort of a polygon or just some sort of shape that is bounded, then it will always have a minimum or maximum. And they may occur other places, but they will for sure occur, the minimum and maximums will be at these vertices. So maybe it happens to be all the way along this line as a maximum, but if this is a maximum and this is a maximum, they will occur at the vertices for sure. And then here's an example of an unbounded region. So we have, when you shade it, it continues forever going down and to the right. And on unbounded regions, you've got to figure out, you will have a min or a max, and you won't have both. But you've got to figure out based on what is going on, whether it's a min or max. And the things that you're going to min or max, it will give you an equation that you need to find the min or max of. And it depends on what's going on, where the min and max are. So the different equations can be different min and maxes. But the kind of things we're going to be doing today are going to be maybe minimum cost or maximum profit, something like that. I need you guys to, on your graph paper on your desk, I need you to graph these three inequalities, shade them, and after you shade them, find the vertices, if there are, however many there are, and then we'll go from that point. So hurry and graph those and shade them. All right, after you graph this, you do have, this is something you haven't ever done before. This is the function that you're trying to find the maximum of. So this is just saying it's a function in terms of x and y that has an x and a y in it. And that's what you're trying to find the minimum and maximum values of that function. So it depends on that function where they're going to be. So your graph should look like this, right? Y equals 4. Here's this one. Remember we did y-intercept of 2, x-intercept of 2, draw a line. If we wanted to do it that way. And then the vertices. So you're looking at these three vertices right here. And you have this function right here that you're trying to find the max and min on. So you're going to take these vertices, and here's an x-coordinate and a y-coordinate, and you're plugging it into this function, and you're seeing where it's the biggest and smallest. So I'll just show you. We'll do another one. So here's your three vertices. Here's your function you're plugging it into. I don't know if this word calls it, but it's like the objective function. It will. And if we're doing story problems, we'll have to figure it out. Like it will say, this costs this, what's the minimum cost? And you have to make up your own function. And then you plug it in. And on this one, you can see it's bounded, so it should have a min and a max. The minimum is negative 14, so out of all the points you could plug into there. Now there might be another place where it equals negative 14, but negative 14 is the smallest value, and 21 would be the biggest value that you could get into this function. So depending on what the question asks, this one just said find the minimum and maximum value. This one has a max of 21, max of 21 at that point, and a min of negative 14 at this point. Yeah.
That's good.
Like if I had a different equation, so maybe I change the equation and I have a different function in x and y, and I say, this is my objective function for some reason. So maybe this has to do with x is the number of wheels you can make, and y is the number of something else, and you want to find the maximum number you can make or something. want to plug that into that, you would still do the same thing. I would still plug in these points right here because the min and max of this right here, no matter what your function is, the min and max is going to occur at one of these 3 points. So I could plug in other ones, but then I could just plug it in right here. Well, I guess I could just put f of that, right? That would work. That would be negative 4 plus 28. So that one would be 24. 10 plus 28. And this one would be 10 minus 21. So if this were my objective function, this would be the maximum, and this one would be the minimum. On this one, it is just giving you the number, so it's saying this is your objective function you're trying to maximize. It gives you 3 lines to graph and shade. After I graph and shade them, 2 of them end up being parallel. Okay? And so there are only 2 vertices. You have this vertex and this vertex. And if you look at it, if you want to find, you plug in this vertex, and then the other one is when you plug in this vertex, you get 2 times negative 2 plus 3 times 0. So negative 4. So you get negative 6. One of these is either a min or max, but you have to figure out what it is. So you have to think to yourself, okay, if I plug in a number clear out here, so I'm coming out, so it's going to be a really big x and a really big y, right? Something. Is this function going to be really big or really small? Really big. So that must mean that this is the minimum, and the maximum has no max. So you could plug in something that's over here, and you could get a really big number, and I could plug in something farther, and I get an even bigger number. So this one happens to have no maximum. But the minimum did occur at this point, and it was this. Okay? We have a landscaping company, mow lawns and prune shrubs. The company can schedule 1 hour for every mowing job, 3 hours for pruning. Each crew is scheduled for no more than 2 pruning jobs per day, for whatever reason. Each crew's schedule is set for a maximum of 9 hours per day. On the average, the charge for mowing a lawn is 40, and the charge for pruning shrubbery is 120. Find a combination of mowing lawns and pruning shrubs that will maximize the income of the company. So I think sometimes, as I started to look at these, you want to maximize the income. So if we could just make the objective function like that we're trying to maximize, then maybe we can make the rest of the equations because we'll know what our variable is. So like if I want to do income, so let me just put an I for income. What is your income in this situation? What do you get for your income? You get $40 for mowing and $120 for pruning.
So it's just $40 an hour either way.
True, don't say that though.
Why?
Well, it just ruins what I'm trying to do. But it's the same, yeah, no matter what, they would be the same amount. Which is why this maximum occurs along the whole line. But, so that's true. But so you're going to make $40 times the number that you mow, right? So if I let M, this is where it's hard. You can figure out your variables. M is the number of mowing jobs, and I make 40 times M, that's how much I make mowing. And how much do I make pruning? 120 times however many pruning jobs I have. So N is my mowing jobs, P is my pruning jobs. So that's the function I'm trying to find the maximum of. I need to find the max of this. And I have to have it under these different constraints right here. So I want you guys to see what equations you can come up with. Use M for the variable for number of mowing, P for the variable number of pruning, and see what you can come up with right here. There are actually 4 equations. If you can find 2, show me 2, and then Two of them are kind of weird. They're actually the easiest ones once I talk about them. But there are 4 equations. I want you to write them on your whiteboard and tell me. So if I look at the pruning, what does the pruning have to be? What's the most pruning you can do? If P is the number of pruning jobs, 2. So that makes sense, right? And then I can only use 9 hours. So this is going to be 1. The hours have to add up to less than 9. So how many do I use mowing?
3P plus.
3P, you want to do the pruning first? 3P plus 1 for mowing, less than 9. Okay, I didn't see any of the other 2 equations, the crazy ones, but hopefully you think about them. I don't know what that middle one is. But, yeah, you can't have negative amount of mowing jobs or pruning. And those are going to be the hardest ones. If I give you a test question, you have to remember that they have to be bigger than 0. It's a storage problem. The negative numbers don't make sense in. So you have your 3. If you graph them, it looks like this. So here's, and some of yours are going to be bigger numbers. Like if they're small numbers, you can graph them and see where they cross pretty easy. But we're going to graph some on your test and on homework that's bigger. So right here, less than 2, greater than 0 puts me in the first quadrant. And then you have this one right here. And Brendan already said that you could do, like you could do all, oh, this is a good thing to realize though. We were thinking we could do all mowing. But look, the most amount of mowing you could do is 9, right? So I guess that works. You could do 9 mowing. And some of you guys said the mowing has to be less than or equal to 9. That's fine too. If I add that in, all that does is shade this way, which just the place it crosses is in the same spot. So that one didn't add anything extra, although you could put it on there. And then you have to see which one's going to give you the most. Either way, it's all 40 bucks an hour. We decided. But if you look at it, this one, obviously the corner that's 0, 0, here is the minimum. Here's the minimum amount you can make, which obviously makes sense. And then these 2 both happen to be a max. And one thing you could realize on this, and I'm not, if you say they're both maxes, then you can just be done. But notice that this one was a max right here, and this one was a max right here. Anything that uses all the hours is going to be a max. So I guess the only other possibility besides 3 and 2 and 9 and 0 would be integer possibilities. So you could actually, if we plugged in 6 and 1, 6 mowing and 1 pruning, that would also be a max. But I'm not going to make you figure that out. This is just saying a max has to occur at one of these points. It actually occurred at 2 of them, and it could occur here. But for sure, you know it's going to be at one of the vertices, no matter what. You're just trying to find the maximum way. All right, to graph this one, I'm looking at the first one. They're all solid lines, so I'm going to choose a solid line and choose 2 points. If I want to choose the x and y intercepts, that might be easy, because if I look right here and I let y equal 0, so I ignore the y, then x equals negative 2. So negative 2 is the x-intercept. And then I look and I let x equal 0. So I have negative y equals negative 2, so y equals 2 is the y-intercept. Oh, I totally did that wrong, huh?
Yeah, I was.
So x-intercept we said was 2, y-intercept was, now I did it wrong again. Okay, x-intercept was negative 2, y-intercept was 2. So there's that one. This one, do you guys see how I'm doing the x and y intercepts? I'm plugging in 0 for x, so the y-intercept in this one's negative 1, x-intercept negative 2. So y-intercept negative 1, x-intercept negative 2. And then for the last one, it's y less than 2, so it's just a line right here at 2. And now you've got to see where they're all shaded.
Probably inside.
Possibly inside, and then once you figure it out, you've got to shade it wherever it's at. So it's less than the top line. This other line that's at -1, it's greater than it, it's above it. And this one, it's above it as well. So it is above it, and below it, right? So right there. I don't know how to shade it yet. Or maybe I shaded the line. Is that what I did? Oh, there it's shaded. Okay, what did I do?
I think it's just those two buckets.
Oh, there's two buckets. Okay, I don't know. I think, yeah, I probably did two buckets, but that was right. We did it right, didn't we?
Yeah.
So, first off, I think the easiest way is going to be if you find your equation that you want to maximize or minimize, and then you make up, write out what your variables are so you know that like x equals this or y equals this or whatever you want to do. So on this one, 350 acres of cropland. You have corn and soybeans you're planting. Corn is a profit of $3.95, soybeans $2.90. You're limited by the number of hours because corn requires 3 hours of labor per acre, and the soybean requires 2 hours of labor. So how should the land be divided in order to maximize the profit? Which of these numbers have to do with your profit? Profit in corn is $3.95, soybeans $2.90. So what am I going to do for my profit equation? $3.95 times X, which is going to be acres of corn, plus 290 times Y, and Y is acres of soybeans. Okay, there are 4 equations again. I want you to see what equations you come up for the constraints. What inequalities are there? You know things we haven't used. You know you have 350 acres of cropland. You know you have 900 hours of labor. Corn requires 3 hours per acre, and soybean requires 2 hours per acre. That information should go into 4 different equations. What were the 2 simple equations to come up with that were fast?
0 is greater than or equal to x. 0 is greater than or equal to y.
Okay, I really can't think of it that way. Okay, the other one of them was this one, so if you haven't done it yet, think of this, 350 acres. X is acres of corn, Y is acres of soybeans. So what's an equation to do with 350?
350
Yeah,
less than or equal to.
that one?
Yeah.
See, I can't do the 350 greater than or equal to, that just blows my mind. Yeah. That would be greater than 0. It has to be, well, but they're trying to find the maximum profit. Maybe the maximum profit is only planting corn. So you never know. So you got to just do greater than or equal to 0. And then this one has 3 hours of labor for corn, soybeans 2, and you have 900 total. So that was 3x plus 2y? Less than or equal to 900. So I want you guys to do a sketch of that. I mean, I can go like this pretty fast. Sketching it by hand. What are the x and y intercepts of this one right here? X is 350 and y is 350, right? So I don't know exactly where that's going to be, but it'll be 350 and 350. And it has to be everything less than that. So I'm less than that so far. What are my x and y intercepts of this one? It says to 900. It's easy to do that one. 0, 450. Okay, so the x-intercept is 450, and the y-intercept is 300. So it's something like this, right? I don't know exactly. Close. And it has to be less than all those, so it ends up being inside here. Well, obviously the maximum profit is not going to be at 0, 0. It is going to be the minimum profit at 0, 0. You have this one, 350, 0. That was easy to find. And this one's 0, 300. That's easy to find. I just need to find this one, test them, and see which one's the maximum. And then after you do that, you should plant this many acres of corn, this many acres of soybeans, maximum profit, and you have to find the point. So, should we graph this on the calculator and see how to zoom and calculate it? Should I go do that?
Yes.
Okay, so help me come up with the equations. Once I have my equations in, and I can tell right now where I need my window to be. I don't know, let's see what happens if I hit zoom fit, but I need it to be, we kind of graphed it, so we know that we need the x coordinate to go out to around 400, and the y coordinate, I need it to go up past 350. It was at 450 for that y-intercept. So if I just go to here, I should be able to see the graph, and that looks almost like the thing I graphed, right? And I just want to find, I mean, I can solve this. It really is, this is probably taking more time than it took me if I just wanted to solve it by hand. But if I want to calculate where they intersect, 200 and 150.
Yeah, 200 and 150.
And it may be that you want to plant all one of these. So now you just need to plug in these points in to here. You need to plug in 0 and 300, 200 and 150, and 350 and 0. Plug them into here. See which one of them yields the maximum profit. You have 12 units of carbs. Let's kind of look as we go. Suppose it takes 12 units of carbs and 6 units of protein for Jacob's minimum weekly requirements. A certain meat is 2 carb and 2 protein, and a certain cheese is 3 carb and 1 protein. I don't know why this meat has carbs in it, but yeah, it has breadcrumbs in it.
Breaded chicken.
Yeah. Meat cost, so this one is cost, this is all about the cost. Meat costs $3.80 per pound, cheese costs $3.90 per pound. Minimize the cost. So that's your clue right there, because if you're confused between the carbohydrates and protein and cost, and meat and cheese, there's so many things that could be the variables. So if I do the cost, what is the cost? Because that's what I need to minimize, and that's going to be my variables. I have meat cost $3.80 per pound, so what am I doing for the cost of the meat? $3.80, and if you want to say X, so let X equal the number of pounds of meat, right? So that's your variable. Sorry, good stuff. Plus $3.90 is the number of pounds of cheese. I don't know why I'm changing. Okay? So you know X has to be greater than 0, Y has to be greater than or equal to 0. All of this has to do with pounds of meat and cheese. It doesn't, the variables are not the number of carbs and number of protein. It has to be at least 12 carbs and at least 6 protein. So if meat and cheese are my variables, that's where you have to come up with the other equations. So what has to do with the carbs and protein in meat and cheese? How much you need and what's in each one? What do you guys think? This is the meat. This meat right here contains 2 carbs. So if I do 2 times the number of meat, that's how many carbs. So really, maybe we should just talk about carbs. how much carbs does he need? He needs 2 from the meat, and how much from the cheese? 6, oh, 3 from the cheese. So this is his carbs. He gets 2 from the meat, 3 from the cheese. What's the minimum amount of carbs he needs? 12. So it has to be greater than or equal to 12. Right? And so now you look at the protein. So this is where your proteins come in. It's just as a separate equation. Cameron, quiet. How much protein is he getting from the meat? 2 from the meat and 1 from the cheese. And how many proteins of meat does he need? 6. So you're going to have these 4 equations. So something like this, another one like this, and another one like this. Whoops, not like this. And it's going to be something like this again, except for it has to be at least this much, so it ends up being shaded this way. And you're going to have your vertices right here, whatever they are. And you'll see how much meat and cheese you can have.